This lesson is simplifying numerical radicals. Now this first one says the square root of 9, which we know the square root of 9 is 3. 3 times 3 is 9. And the square root of 36 is 6. Now these are all nice and neat because they're perfect squares. So now the question is, what if the number underneath is not a perfect square? Can you break them down? So we don't want any decimals. We just want to break it down and simplify it. So here I've listed the perfect squares for you. So 2 squared is 4, 3 squared is 9, so on and so forth. I went all the way up to 15 squared, which is 225. I always think it's good to memorize those. So again, I put 2 to 15 up there. So our first example here is the square root of 8. Now the square root of 8, again, 8 is not a perfect square, but can you break it down? So the way we do that is what we want to ask ourselves is there a perfect square that is a factor of 8? Which in this case, yes, this is 4 times 2. 8 can be rewritten as 4 times 2. And now we ask ourselves, can we take the square root of one of them or both of them? Well, the rules with roots, when you square root a number, if you have two numbers being multiplied underneath, technically you can break that up as the square root of 4 times the square root of 2. Which, we could say the square root of 4 is 2, leaving that other 2 underneath the root. So your answer would be 2 root 2. And again, that's the way to do it when you know the largest factor of our starting number that's a perfect square. Now you can also do the factor tree if you like that method better, which you'd say 8 is 2 times 4, 4 is 2 times 2, and you circle a pair of factors that are the same. So that number comes out front, and then whatever number did not get circled, which is this remaining 2, that stays underneath the root. And if you do it the right way, again, if you circle the pair, you should end up with the same number as the first method with finding the largest perfect square as a factor. So let's look at this next one. We have root 32. So root 32, if I were to drag this down here, we have root 32. The largest perfect square would be 16. So that would be 16 times 2. That is the same thing as 32. And so now we could say, well, we could take the square root of 16, and that gives us a 4. But again, we have that 2 still on the inside. So our answer would be 4 root 2. We'll just do one more here, and then we'll continue on with a little bit extra of a problem. Now we have root 75. Root 70, again, 75 is not a perfect square, so as you work your way, 4, 9, 16, 25 is a factor of 75. So this can be rewritten as 25 times 3. There you go. And now when you take the square root, the square root of 25 is 5, leaving you with that 3 underneath. Now again, it's the biggest perfect square that you can take. So if I were to give you 200, excuse me, and take the square root of that, notice 4 is a perfect square, and it is a factor of 200. But the question is it the largest perfect square? Again, you could do the factor tree, sure, or you can just find the largest factor. So in this case, 100 would be the largest factor that's a perfect square. So 100 times 2, which you take the square root of 100, which gives you 10 root 2. Now what if you just, I don't know, for some reason you forgot that 100 is a factor and you just went with another factor. So what if you actually did go with 4? You could break down root 200. You could say 200 is 4 times 50. And you would take the square root of 4, which is 2 root 50. But then you always want to ask yourself, the number that's left underneath the root, can I break that down? Well, in this case, you can break 50 down to be rewritten as 25 times 2. and then you could take the 25 out. Well, since there's a 2 already there, you're going to leave the 2, but then you're also going to bring the square root of 25 out, which is a 5. So now you have a 2 and a 5. When you multiply, you get 10, leaving you with the root 2. So notice we get the same answer. So if you can't figure out the largest factor, but you know there is a factor of the number that is a perfect square, you could just break it down one little step at a time. Okay? Let's take a look at another example here. We have 3 root 98. 98, so we see 4's not, 9's not, 16, no, 25, 36, 49 is a factor of 98. So again, we have the 3 remaining on the outside. 98 can be rewritten as 49 times 2. Take the square root of 49, and again, we have the 3. We're bringing the square root of 49 out, which is 7, leaving the 2 underneath. And any numbers that are here on the outside, we're going to multiply. So that gives us 21 root 2. Alright, so that's how we deal with some simplifying, just some very basic simplifying of square roots. And I hope that helped you.